Now, some of the special word problems we have that require a formula to solve are percent of increase and percent of decrease problems. You're familiar with some of these because you add tips based on the price of a meal. You do a percentage of the meal and you're increasing it. You buy shoes or clothing that is on sale. You decrease the amount of the price of the clothing by a percentage. So let's work a couple of these, but first I need you to learn a couple of formulas. The percent of increase formula is the original price or the original amount plus, and then we have to take the percent and multiply it times the original, and then that's equal to the final. Decrease is the same. The only difference is we subtract our percent times original instead of add. So it's easy to memorize these two formulas. Example 1 is a good one for us to start with. It says a birthday celebration meal is $40.50 including tax. Find the total cost if a 15% tip is added. Now, added means that we're going to use the percent of increase formula. So we always write the formula down so we don't mess up. We're going to say original plus, and then we say the percent times the original, just so we remember what we're doing, equals the final amount. Now, I fill in all of the information I know. Now, there's two pieces. There's an original, there's a percentage, and there's a final. Three pieces, sorry. So the original is used twice in the formula, you note, which is why we can only use, we have to use the formula to solve some of these types of problems. Otherwise, there's no other way to do it. So I've got the birthday celebration meal is $40.50. That's the beginning, or the original price. I'm going to say 40.5. I could say 0.50, but it doesn't matter. And that's going to be plus, and where else do I plug in the original? Well, right here, times the percentage. I'm going to say 40.5 there equal also. Now I say is equal to the final amount. Well, do I know the final? It says find the total cost after the tip is added. Well, that's the final. That's my unknown. That's X. Well, what's the percentage? Well, they told me I'm going to give a 15% tip. So that's going to be 0.15. Remember, percents always have to be represented as decimals when we're doing math. So really, what am I doing? I've got too many dots here. I'm going to represent my multiplication with parentheses there to make it a little clearer. I'm going to say 40.5 plus, and then I'm going to multiply first. I'm going to say 0.15 times 40.5, and that's going to equal X. Well, let's do the multiplication first. That's what order of operations tells us. I've got 40.5 times 0.15. 5 times 5 is 25, carry the 2. 5 times 4, 20. Put down a 0 and multiply times the 1. 5, 0, 4. Add these two numbers. I have 5, 7, 0, and 6, and 1, 2, 3 decimal places. So my answer is 6.07. Well, now that's the tip, remember? But I'm not going to give somebody half of a penny, so I'm going to round this up to the nearest penny. It would be 6.08 or $6.08. So my original was 40.5 or 40.50 plus the $6.08 tip, and that's going to equal the final amount, or X. I still have to add these. I'll move my $40.50 plus $6.08 tip and add these numbers together, bringing down the decimal in the same place. Remember, when I'm adding decimals, I have to line up the decimal place. When I'm multiplying them, it doesn't matter because I'm just going to count the number of decimal places and place that in my answer. So the answer, the final amount, is $40.58, and that's my answer. And now example 2 says find the original price. This is the problem that you really cannot do any other way but with this formula. The original is my unknown. So the original price of a pair of shoes, if the sale price is $78 after a 25% discount. It is a percent of discount formula, so I'll write that down. Original minus percent times the original, and that's equal to the final. They've given me everything except the original. So let's fill in everything, and let's call the original X. Original minus the percent this time is 25%, or 0.25. So I'm going to say 0.25 times X, or 0.25X. And that's equal to the final, which the sale price was $78 after the discount, so that would be 78. Now, I've got to combine x and negative 0.25x. That looks confusing until you remember that x is really 1x. And if I say 1 minus 0.25, what I really have left is 0.75. That's how many x I have. 0.75x is now equal to 78. I will solve by dividing by the coefficient of the variable term, so I'll divide both of these sides by 0.75. So I'm saying 78 divided by 0.75. Remember, I cannot divide by decimal place two places. So I'm going to have to move this one 2 places also and place the decimal in the answer. Now, I'm going to say 75 into 78 goes one time. Subtract, bring down a 0, but I can't divide 75 into 30, so I'm going to have to put a 0 there and bring down another 0. And 75 into 300, I believe that number is going to be 4. I'm going to try it. 4 times 5 is 20. Carry my 2. 4 times 7, 28 plus 2, 30. It worked. So x was going to be equal to 78 divided by 0.75, or 104. That is the price. $104 is the price of the pairs of shoes, the original price. Then it was discounted 25% to $78, and that is correct. Now, we've looked at this problem two different ways. We've looked at it when the example 1, when the final was unknown. Example 2, the original is unknown. And now we're going to look at it when the percent is unknown. This one, example 3, says iceberg lettuce is grown and shipped to stores. It's about 40 cents a head. That's what it cost. That's the original price. Consumers purchase it for 86 cents a head. Now they want to know the percent of increase. Well, they told us it's increase. Write your formula. Always start with your formula. So it's original plus percent times original, and that's equal to the final amount. Well, we know everything but the percent. We know the original, it starts at 40 cents a head, and then we add the percent, which is unknown, so we'll call it x times the original, or x times 40, and that's going to be equal to 86 cents. Now, I didn't represent the cents as decimals, but I could have. It's just easier for me to represent them all as whole numbers. Let's say this 40 is really 40 plus, we would normally write it, x times 40 would be written 40x is equal to 86. Let's get rid of this 40 that's added to our variable side. And we have 40x is equal to 46. Now we need to divide both sides by the coefficient of x, which is 40. And we're going to say 46 divided by 40. Looks like we're probably going to need some decimals to do this, so I'm just going to put a decimal and add a 0 just in case I need it in my answer. 40 into 46 goes one time. I put down 40 and subtract. 40 goes into 60 one time. When I subtract, I'm going to need to bring down another 0, and 40 would go into 200 5 times. And my answer, x, is going to equal 1.15. But remember, this was the find the percent. So I have to translate my percent to a decimal. I always have to do that when the unknown is the percent. I have to move it 2 places to the right. When I add a percent sign, I move it toward the percent sign, and it becomes 115%.